This assignment, I built a decision tree model to predict whether someone might be infected with COVID-19 based on symptoms like fever, body pain, runny nose, and breathing difficulty. This dataset is loaded from corona.csv and contains multiple features, which is foundation of our analysis. To get started, I imported key libraries, pandas for data handling, train test split to divide the data, decision tree classify to our model, accuracy score to evaluate how well it performs. Then I loaded the dataset using read CSV and preview it with df.head just to make sure everything looked right. This helps confirm that the file loaded correctly and allow us to inspect the features and labels before processing and training. Using df.info and df.describe, I confirmed data was ready and the average fever is around 100.5 degree Fahrenheit and the age range is 12 to 82, and most features are binary, perfect for classification. To prepare the data for modeling, I used df-drop infected exists 1 to separate this feature like fever, body pain, age, info into X. The target level infected was stored in Y. This step is crucial because machine learning model learn patterns from feature X to predict the target Y. Model accuracy 0.49. After training the decision tree model, I evaluated its performance. The accuracy was around 49%, meaning it correctly predicted infection status in roughly half of the case, not ideal for generalization. To dig deeper, I used a confusion matrix. It shows true negative 144, false positive 147, false negative 157, true positive 152. This imbalance suggests the model struggles to distinguish between infected and healthy cases. Overall, it's useful starting point, but improvement like better features or a different algorithm are needed. Here I am showing the classification report for the model. The precision recall and F1 score for both are all around 0.49 to 0.51, showing weak performance. Accuracy was 49%. The confusion matrix revealed many false predictions, meaning the model struggled to separate infected from healthy cases. Next, I extract feature importance from the decision tree to understand which symptom prediction the most. Feature importance showed fever and age were most influential. Runny nose and body pain had minimal impact. Overall, it's a starting point, but improvement are needed for better result. Let's start part B. I started by importing pandas, matplotlib, and seaborn for data handling visualization. Then I loaded the dataset from assignment 2 CSV and dropped the model column using df.drop column name model. This cleaned up the data by removing irrelevant information. Finally, I used df head to confirm the column was removed and preview the first 5 rows to ensure the dataset is tidy and ready for analysis or visualization. Now, the clean data includes only relevant columns like cost, continent, and zip code, ready for real analysis. In this step, I cleaned the cost column because the values included symbols like square brackets and dollar sign, which interface with calculation. I used string replacement with a regular expression to permanently remove those characters. After cleaning, I ran head again to confirm the values looked numeric, but even though the symbol were gone, the column was still stored as object, meaning it was treated as text. Since machine learning model require numeric format, the next step is converting its column into integer to make it usable for analysis and modeling. In this step, I converted cost column from text format to an integer format using s-type int function. This is important because earlier the values were stored as string even though they contain numbers. Machine learning algorithm and mathematical operation require numeric data types. So converting the column ensure that the data is usable for calculations such as averaging, grouping, or training models. After converting the cost value, I printed the data type of all columns using DFD types. These allow me to confirm that the conversion was applied correctly. The output shows the cost column is now stored as int64, which means the data is ready for numerical analysis. In this step, I calculate the overall average cost using the mean function. This gives a single summary statistics that helps us understand the typical value in the dataset. The result shows the average cost approximately 54.63. Average cost by continent. Next, I group the data by continent and calculate the mean cost for each region. Grouping data is useful because it allows us to compare categories instead of only looking at the entire dataset as one population. From the output, Australia has highest average cost while South America has the lowest. These differences can help identify geographic patterns, support decision making, or later be used as features in a machine learning model. Here I created a bar chart to compare the mean values of numeric column grouped by continent. This visualization makes it easier to identify patterns across region. We can see a noticeable variation in features like range, value, and cost between continents. Using chart like this provides clearer insight than raw number alone and helps support analysis of future machine learning decision. In this step, I analyzed the continent column using value underscore counts to see how many entries belong to each region. This helps identify the distribution of data and shows whether the dataset is balanced. Then I used unique and unique to display all distinct continent names and confirm there are 7 unique categories. This type of categorical analysis is useful before performing grouping, visualization, or encoding for machine learning model. In this step, I used value counts function to analyze the frequency of value in the cost column. This shows how many times each cost amount appears in the dataset. Understanding frequency helps identify common price ranges, detect outliers, and decide whether additional transformation or grouping is needed before visualization or machine learning. Here I created a histogram to visualize the distribution of the cost column using 50 bins. Gives us a more detailed breakdown of how values are spread across the dataset. This visualization helps identify patterns such as clustering, variation, or potential outliers. Histograms are useful for understanding whether the data is uniform, scared, or concentrate in certain ranges. In this step, I checked for missing value using isNull.sum function. This helps identify incomplete data that may affect analysis or machine learning results. The output shows that the zip code column has 9 missing values and the type column has 2 missing values, while the rest of the dataset is complete. Identifying missing data is an important pre-processing step before deciding how to fix or remove those values. In this step, I examined the type column and included missing values in the count using value counts. Drop now equals to false. Then I replaced these missing entries with a placeholder value using fillNa function. After cleaning, all values are now valid and the dataset no longer contains empty cell in this column. This ensures consistency and avoid error during analysis or machine learning processing. In this step, I removed any rows that still contained missing value using dropna, which reduced the dataset to 941 rows. Then I used describe function and indexing to extract the specific summary value. Lastly, I stored the frequency of continent alphabetically using sort underscore index. This final step helped ensure clean, organized data and make the dataset ready for future analysis or machine learning processing. So, in conclusion, this project helped me walk through the full process of working with data, from cleaning and organizing it to analyzing patterns and finally building a machine learning model. Even though the decision tree model reached around 49% accuracy, it still gave meaningful insights, especially about which features are most important, like fever and age. Overall, this was a great learning experience because it showed how important data preparation is before modeling, and it gave me a strong foundation to continue improving. My name is Najnin-S, and thank you for watching.